Alright, welcome to Academic Diaries class. So they said, given this circuit, they said we should find the current in the 10 ohm resistor using Norton's theorem. And I've told you that whenever they tell you Norton's theorem, all you need to do is to short circuit. Short circuit simply means let it become a wire. Short circuit that resistor, they're asking you to find the current there. And when you short circuit it, you use nodal analysis to get your answer. So that means we have to redraw that circuit. So let me redraw it. So I've redrawn it. This becomes our 5 ohm. Then this place that you have the 10 ohm resistor becomes IN, because that's the Norton's current you're finding there. So this is the 2 ohm, this is the 8 ohm, and this is the 15 ohm. So now that you've done this, the next thing is to find the direction that your current will be traveling. Now to find the direction, it simply means get the nodes. And I've told you what node is. It simply talks about a point where 2 or more wires meet. And how to determine this in a circuit is using sources. Sources are things like resistors, voltage, capacitors, ammeters. So you can see that this is a resistor, this is a voltage, this is one node. This resistor to this resistor is another node. This voltage to this is another node. So that's the top node. So let's draft it. So that means I have a voltage up to this resistor, that is one node. And for a node, if it's node 1, that is, it will have the voltage 1. So this is 20 V. This is the 5 ohm. So for node 1. Now for node 2, it will simply be starting from that 5 ohm resistor, travel down to the next resistor. It will stop there. But notice that as you're traveling, you have on the inside, hey, you're not supposed to have this wire. So it stops at the source. Okay, let me just project it. It stops at the source. So let this be the 15 ohm. Now, and if I project this as well, this becomes the 8 ohm. It stops there. So that's for the node 2. Now for node 3, starting from that 2 ohm resistor down to the voltage on the right hand side, which is 10 volts. Remember, this is 20 volts. This is the main diagram. So if I do that, that means for the top node I have 3 nodes. So this is, everything here is V2 since it's in node 2. Everything here is V3 since it's in node 3. So remember that what I have here is 2 ohm, and what I have here is 5 ohm. What I have here, this is the same 2 ohm. Yes. And notice that resistor to voltage there, this is now among node 3, so take note of that. So now for the fourth node, the fourth node is simply going to be everything from this voltage to this voltage, because there's no resistor, there's nothing, no source in between. So that means it's just 4 nodes. And remember what I told you, whenever you have 4 nodes, you should have like 3 equations. So now notice this is going to be the voltage one way, then this is 10 volts, this is 20 volts. Now notice that as you're doing that traveling inside, on the inside you have your resistor. This is 15 ohm, this is 8 ohm. So that's it. So everything here is V4, 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 V4. And because there's nothing in between, it's always perfect when you don't have a resistor on the ground to call the center part of that your ground, that's your ground, and on the ground there is no voltage. So that means that V4 here is equals to 0 since it's your reference. So note that we have just 4 nodes here. So since we've gotten V4 to be equals to 0, this is like our equation 1. Note that. So let's go to the next one. If we now have to solve, because we've been able to get the nodes, the first is to get the nodes, the next thing is to get the direction of currents. So now notice, to get the direction of current, this is positive. Bigger part of the battery is the positive, smaller part is the negative. So remember that we said that current enters the battery through the positive terminal and leaves through the negative. So since that is the case, if this is entering, which current is this thing that is flowing? Is this 5 ohm? which is here. So it's moving from here. So that means the direction of this current is this way. Now, this is positive on this. This is positive side of this battery. This is negative. Current enters here. Which current is this entry? Is the current traveling through this 5 ohm resistor, which means it's going this way. So come and put it. So let's call this I1. Call this I 2. So okay, but I want to call it. I want to. Okay, let's go with it. No problem. So this is going to be I1. But before that I1, I have this. But let's just follow it. I2. Okay. Then on the inside, I can see that this particular node, we remember that we said that potential, that is voltage, current moves from higher potential, region of high voltage to low voltage. So we always take it that node 1 has more voltage than node 2, and node 2 has more voltage than node 3. So the ground has the lowest node. So for that reason, if this is from node 2, it should be traveling down to meet the ground or to meet node 3. So this is moving down. So for that reason, this is this current here. Let's call this one I3, and let's call this one I4. This current is simply the current inside the resistor. So this is I3 and this is I4. Okay. So now that I've noted that, let me do the same leveling here. I3, I4. Remember, this is the 2 ohm. This is this one. This current here. The current here is this. So this is our we chose this to be I2. It's not must you number your own with what I've numbered, with what I used, like calling it the arithmetic 2, 3. You can choose to name your own A, B, C alphabetically, but just get the direction. That's the main thing. So this is I1. Okay. So now that we are done getting our currents, you see sometimes people will have 4 nodes, they'll be getting up to 8 currents. It means you are wrong. So if you have 4 nodes, you should have 4 currents. You have 5 nodes, you should have 5 currents. If you have 10 nodes, you should have 10 currents. Yes, because there are so many direction currents will move, but the final destination or the final direction is determined by higher potential moving it to lower potential. So having that in mind, it means that you should always have current that is equal to the number of nodes you have. So now that we've gotten this, let's now get the equations. So the first thing is to draft the nodes. The second thing is to get the current direction. The third thing is to draft the equations. And remember, I told you if you have 4 nodes, you should have 3 equations, because one of the equations, the last one, should be the ground. If you have 5 nodes, you should have 4 equations. If you have 20 nodes, you should have 19 equations, because the 20th one should be the ground or your reference. So now let's get the equations. This is going to be from node 1. From node 1, I'm going to be having watch. This is node 1, V, and I have this current entering it. But remember, I've told you, anytime you have a node and there is a voltage in between, simply say the voltage up minus the voltage down equals to the middle voltage. So you can see that current enters this from the top, from V1, and where is it going? To the ground. Let's number this. This place is V4 and V4 is 0. Everything here is V4, V4, V4. So this is like the full diagram. This is V1, this is V2, V2, V3. So if you know this, it simply means that V1 to V4 is having, so it's going to be V1 higher potential minus V4 is equals to that middle, which is 20V, and V4 is 0. So V1 minus 0 is equals to 20V, which means that V1 is equals to 20V. This is equation 2. Equation 1 was the one that gave us V4 equals to 0. Once you choose your reference, that's the ground, that it becomes your 0. Now that I've gotten that, I told you that once you are able to do this, what's it called? Anytime you do this, uh, upper voltage minus or higher voltage minus lower voltage equals to middle voltage. Once you do this, always find the super node immediately. And super node is simply if you overlook all the voltages there, both the up, the down, the middle, what currents are pointing to the up, what currents are entering the upper voltage and leaving the upper voltage, and what currents do you have entering the lower voltage and leaving the lower voltage. So let's say super node equation 1. So super node 1. So to get that, we'll come to this place. We'll see that I1 is entering the upper voltage, which is I1. Anything entering is positive, anything leaving is negative. I1 is entering positive. Now, lower voltage is V4. What is entering V4? Entering V4 is I3 and I4. Any other currents? So just this. So let's go to the main circuit and check if we are correct. You can see that if this is the node, this is the node. If this is this node V4, V4, V4. What are the currents entering? This is entering it. This is entering it. So that means that is equals to 0. So now let's check something. I1 that you have here is in between V2 and V1. So you say V2 minus V1 all over. What is the resistor in between? 5. Why am I saying V2 minus V1? Because see that the direction is this way. So V2 minus V1. It moves from upper to lower, higher potential to lower potential. So plus I3. I3, where is I3? I3 is in between V2 and V4. And V4 is 0. So you just have V2. So you just say V2. What is the resistor in between? It's 15. That's the resistor there. Plus I4. I4 is in between V2 and V4, and V4 is 0. What is the resistor there? So it's just V2. It's supposed to be V2 minus V4, but it's set as saying V2 minus 0. I don't want to put that. So all over, the resistor there is 8 equals to 0. Now that means that what is the LCM here? Let me do it. It's going to be, is it 120? Because yes, 5 times 15 times 8. Sorry, between 5 and 15 there's a common factor, that is 5 and 3. So if you do it properly, it should give you 120. So this is going to be the same thing as saying if 120 get divided by 5, you're going to be having 24, and that 24 will come here and get V2 minus 24 V1, then plus 120 into 15 should be, if you punch it, it should give you 24. It should give you 8. 120 into 15 should give you 8. Do it and check. So 8V2, then plus 120 into 8 should give you 15. So 15V2 equals to 0. So by the time you collect all the V's, this is V, this is V, this is V, you should be having 47 V2 minus 24 V1 equals to 0. So this is another equation. So this is equation 3. Yes, this is equation 3. But if you don't want to call, okay, yeah, this is equation. Yes, wait. Okay, we are in super node. So this is not an equation for our node. This is super node equation 1. Super node equation 1. So, but we still need to remember. You need to remember that we already have V1. V1 here is equals to 20V. So just substitute into this equation. So if we substitute, we're going to be having, so it makes the work easy for us. Because instead of us coming to find equation node 2 now, there is no need for that. So we can just do, if you want, you can still progress and do it, but we can just do it here. We'll just say 47 V2. Well, because if this 24 crossover becomes positive 24, then V is 20. So this is going to be 480 47 V2 equals to this. So V2 will be equals to 480 over 47. So V2 is equals to 10.21 V. Okay, so that means we've been able to get V1 equals to 20 V, V2 equals to 10.21 V, V3 already. V3, how do we get V3? V3 can be gotten by doing, how is the current moving? Current is moving from this part, entering the positive side and leaving to negative. So you can see that V3 minus V4, V3 minus V4 is equals to the middle one, 10V, and V4 is 0. So V3 is simply equals to 10 voltage, and V4 is equals to 0. So we've gotten everything we need. So assuming you're doubting Thomas and you want to come and get this using equation 2, you can also come here and do it. You can see what are the currents entering here. I1 is leaving. Now I just want to check. Because let's check. So let's say we have I1 leaving. Then we have I2 leaving. So minus I1 minus is it I3? I say I2 minus I3 minus I4. Yes. Then minus I2 equals to 0. Let's check it here. On the second node, this is leaving it. This is leaving it. So everything is leaving it. So let's get I1. I1 is in between V2 and V1. So V2 minus V1 all over 5. I'm just checking to see if I can get V2 from this on the second node, but I've already gotten it. This is a better approach. That is why I say it's a better approach is simply following the rules. If I get a node and that node is gotten by doing the voltage up minus voltage down equals to the voltage in the middle, get the super node immediately. So following the rules, that's it. So we're just making mental assessments. That's what we're doing here. And I3 is in between, this is minus, I3 is in between V2 and V4, that's V2 all over the resistor there, 15, minus I4, I4 is in between V2 and V4 again, and the resistance between is 8, so V2 over 8. Then I2 minus, I2 is in between V3. Okay, yes, V3 and V2. But notice that the current is going from V2 to V3, so it's going to be minus V2 minus V3 all over the resistance between is 2 equals to 0. So let's do this now. The LCM of this, let's check. The LCM of this should be, let me analyze it here. Let me do it. 2, 8, 15, 5. So 2 here, 1, 4, 15, and 5. 4 here, 1, 1, 15, 5. 5 here, 1, 1, 3, 1. 3 here, 1, 1, 1, 1. So let's check. This is going to be 2 times, that is 8 times 4, 2 times 8 times 5, 2 times 4 times 5 times 3. 120. So 120 is what we have. 120 into 5 is it 24? 120 divided by 5, 24. So this is going to be minus 24 V2, then minus times minus is plus 24 V1, then minus 15 into 120 into divided by 15. 120 divided by 15 is 8. So minus 8 V2, so minus 15 V2 minus 120, is it 60? So minus 60 V2 plus 60 V3. Everything here, 120 times 0 is equals to 0, so equals to 0. V2 minus V2. And let's do it this way. Minus V2. This is V2. This is V2. This is V2. This is V2. So I have minus 24 minus 8, then minus 15, minus 16, shit man, okay, 60, 15, 8, 24, so I have minus 107 V2. Then remember, this is plus 24. I have V1 already to be 20. Then plus 60. I have V3 already to be 10. Should is it what I got V3? Yes. I have V3 already to be 10 by doing middle minus down, which is equals to up minus down equals to the middle. So 10. So this is going to be 2 times 20, 40 plus, is it 600? 600. So minus 107 V2 plus this. So this is going to be 640 plus minus 107 V2. So if you check this equals to 0, it equals to 0. If this cross equality side, it becomes minus 640 equals to minus 107 V2. Minus will take care of minus. V2 divided by V2 is equals to 640 divided by 107. 640 divided by 107. So you're getting V2 to be equals to 5.98 volts. So please, I carefully reviewed it. See this place where we have 24 V1. Instead of 24 V1, when I multiplied, I did 2 times V1. So it's supposed to be 24, not 2. So that's why we got the wrong answer. So it's supposed to be 24 times 20 is 480. 60 times 10 is 600. If you times it is 1080. So when you do the math properly, I carefully reviewed it, please. So when you do the math properly, you are getting 10 V2, 10.09. And 10.09 is not far from 10 because this is approximately 10 volts. So this is also approximately 10 volts as well. So V2 is equals to 10, which is what we got here. So we are correct. So pardon, we made a mistake there, but we've corrected it. So this is the way the answer should be. So when you now do it, you now go back and say, if you know that I1, see, we try to use node method so that we get this, and it's the same thing, 10 voltage. V2 is 10 voltage, or you say 10.21. So now the next thing to do in order to get IN is to get out the currents flowing here. So I2 is equals to V2 minus V1. See it, this is I2. Where is I2? I1, sorry. I1 is in between V2 and V1. So V2 minus V1, because the current is moving this way. The resistance there is 5. So it's going to be 10.21 minus 20 all over 5, which is equals to minus 9.79 over 5. So I1 is equals to minus 1.96 ampere. For I2, see, I2 is in between, is going this way, is in between V2 and V3. So we say equals to V2 minus V3 all over. The resistance there is 2. And we know that V2 is 10.21 minus V3 is 10 all over 2. So this is going to be the same thing as saying 0.21 all over 2, which is equals to 0.118 ampere for I2. I3 is in between V2 and V4, and V4 is 0, and the current is going this way, so and the resistance there is 15, so it's just V2 over 15, which is equals to should be V2 over 15, which is equals to 10.21 over 15. I2 is equals to 0.68 ampere. Now I4 is in between V2 and V4. So I4 is going to be V2 minus V4, and V4 is 0. All over the resistance there is 8. So it's equals to 10.21 all over 8. So I4 is going to be equals to 1.28 ampere. So now that you've gotten it, next thing is to come here and look at this very well. Carefully looking at this, you see that IN here, let's do it. IN is in two directions here. IN is, remember, since we said that current is going here, we need to know the direction of IN, that is this here first. Current is going this way, and current is also going this way. Now we need to check, since this is leaving this way and leaving this way, between what's it called, this is 20 volts and this is 10 volts. So yes, the work done, you can choose any direction, but the work done, in as much as current is moving here, but this voltage here is V1 here. This is V1 here, while this voltage here is V2. Current is going this way, but if you are considering this voltage here, the work done in moving things this way will be higher because it has more voltage. So that means I want to choose this direction. You can choose any direction you want, but me, I'm choosing this direction. So if that be the case, there's a level of understanding you need to have about things in order for you to see like every reason behind every detail. So I know if I tell you voltage is here and he wants to move this current, you will start saying, but I'm saying that this current is going this way. The work done, the potential is higher here. If the potential is higher here, it means that it tends to pull things towards this axis. Yes, this current is flowing this way because the positive is on this, it will enter here. But when you consider everything that has to do with direction of current on this wire, if you are talking about the work done, this potential is higher. So it's more like if I have big tank and small tank, that tank will tend to release than the smaller one will do. So for that reason, if I have higher here and lesser here, it's like a slanted slope. So it is easy to move from here to here than it is to move from this end to this end. So if you don't get it, just choose any direction you want. So this is going to be that IN now. Notice that this current here is moving in direction with IN. So it's the same thing as saying IN plus I2. And notice that this particular one here, this junction I4 is leaving, will be equals to I4. So notice that we don't know IN, but we know I2 and I4. So this is going to be that IN will be equals to I4 minus I2, because this will cross over. Also, if you consider this part, notice that this is I1 and this is I3. They are both leaving. And IN also is leaving. So this is the same thing as saying I1 plus I3 plus IN is equals to 0. So if it's equals to 0, it simply means that if I choose now to get IN from this, because they are all leaving, all the currents leaving according to Kirchhoff's theorem, that means they are all equal. Since they are all leaving, this one is leaving here, this one is leaving here, this is leaving as well. So it's more like leaving, leaving, leaving. Don't tell me, but this one is entering. Remember, it's IN we are looking at. So we are checking in this, on this part where this is moving out. This is moving out. This is also moving out. And this is also moving out. It's not like any of them is coming to this junction on this node. So they are leaving this node. They are all leaving this node. Have that in mind. So for that reason, IN going outside now will be, it will be the same thing as saying IN equals to minus everything here. So this is minus I1 plus I3. That is this going outside. So let's now check. Let's check the value. So we remember that we got I4. That is on this first one. That is considering this one. IN. Let me do it here. Okay. Let me continue. I4 is what? 1.28 minus I2 is 0.68. So 1.28 minus 0.68. 0.6. Remember, let's check. Hope we with our, I'm coming. Yes, I4 minus I2. Yes, then check something for me here. Which one give me minus? Yes. Okay. So I got 1.28 minus 0.68. I got 0.6. Wow. Thank you. That is for I4 minus I2. Wait, what am I doing? This is my I2, this is I3. Hi God, what is happening? This should be minus 0.11. That is for I2. I2 is 0.11. I foresee. 1.28 minus 0.11 is giving me 1.17 amps. Now, considering this one, that is considering the second one, that is IN minus. So IN equals to minus I1 is what? Minus 1.96 plus, then I3, what's I3? I3 is 0.68. Treat the bracket first. Treat the bracket first. So subtract this before considering this. So you do, some of you will rush and want to do this. So I'll do minus 1.96 plus 0.68. So so it's giving me my minus 1.28 equals to minus. So this changes to plus IN. Yes. So that is that. So IN is here, approximately here is approximately 1 ampere, and also here is approximately 1 ampere. So that is IN for you. So the value of your IN here is equals to 1 amps. That is your IN. So that's how you go about it. Thank you.